Hello, this is Charlene. We are going to find the rule for this weird sequence of numbers. So a lot of times your teacher will only give you this list. They'll just say this list of numbers, find the rule, and find the sixth term. But what you want to do with this is also number them. This is the first term, second term, third term, fourth term, fifth term, and the sixth term. So you need those numbers because that really helps us figure out the rule. Okie dokie, so we are going to also look at one more piece of information right over here. This is always going to be one of our choices if we're going from negative to positive, negative to positive, negative, and this one will be positive. We just don't know what it is yet. So anytime you have alternating negative, positive, you're either going to have this right here as part of your equation or this one right here. So it's -1 to the nth power or -1 to the n plus 1 power. That piece of it is what's going to allow us to one of the numbers to be negative and the next one will be positive. The next one will be negative and the next one will be positive. It'll be either this or this. That's just a rule. Some people smarter than us figured that out, and it's kind of like you don't want to divide by 0 because that's a big no-no. No zeros in the denominator. That's a rule you need to remember, so remember this. Those two things, one of those two things will be in your equation. Okay, so now let's get back to this part. At this part, we are going to consider what is the relationship between this one and this one. Like I said, we're going to deal with the negatives with this stuff over here. So for right now, we're just going to kind of ignore the negatives. So we want to know, what is the relationship from 1 to 1? How do I get from 1 to 1? How do I get from 2 to 4? And of course, this is also assuming that we've already ruled out that this weird sequence of numbers is weird because it's not arithmetic and it's not geometric. So anyway, so weird set of numbers, weird list of numbers. Okay, so 3, how does it get to 9? 4, how does it get to 16? At that point, you may begin to recognize the fact that if we do 2 squared, that gives us 4. If we do 3 squared, that gives us 9. If we do 4 squared, that gives us 16. Same thing here. 5 squared is going to give us 25. So we've just figured out the next piece of our rule for this weird sequence of numbers. So we're going to either have -1, well, let's go ahead and write a sub n, our rule. We'll start with a sub n, like how do we figure out any of the nth numbers? And it's going to be equal to either -1 to the nth power, or our second choice would be a sub n is equal to -1 times n plus 1. So one of these will be part of our equation. But what we've figured out is that the 1 is an nth term. The 2 is an nth term. The 3 is an nth term. So all these numbers essentially equal the n number. So that means that it's going to be n squared. Like 2 squared means n squared. 3 squared equals, that should be squared if I didn't do that. 3 squared. So everything is being squared along the way. So that means that we are going to put in our equation n squared and n squared. So we're going to test both of these to see which one. Is it this one or this one that we actually want to use? So we're going to go ahead and plug this in. We're going to try the first one, and we're going to say, we want to figure out what the third term is. So according to our equation that we're testing out, it is going to be -1 to the n, which is 3 in this particular case, and then it's going to be times 3, that's the n, 3, squared, and that is going to be equal. Okay, so -1 to an odd power means there's going to be an odd negative left over, which means it is still going to be -1. And then we're going to multiply that times 3 squared. Well, 3 squared is 9, and that -1 times the 9 is equal to -9. And voila, that is actually what we have up here. We have that the third term is equal to -9. The third term is equal to -9. Now, just to confirm that this one is the wrong answer, let's test this one down here. So we're going to say, okay, we're going to figure out what the fifth term is, the fifth term. And that's a funky looking A there. Okay, so we're going to do A sub 5, which means the fifth term. And I'm going to plug it into my equation over here, which is -1. And it's going to be to the nth power, which in this case is 5. So 5 plus 1. And then that's going to be 5 squared. Okay, so if we do equals, and you could do this in your calculator, -1 to the 6th power. Well, -1 to an even power means all the negatives are going to cancel each other out. So that means all the negatives go away, so it's just 1. And then 5 squared is going to be 25. And then 1 times 25 is 25. However, that is not the right answer, right? This is not the right answer because we're looking for a -25. So this one should be our correct equation. This is our correct answer. So this would also be our general equation that we could use to find all these things. Well, they still want us to find the sixth term, so let's go ahead and do that. Let's go ahead and do A to the 6, or sub 6, which means let's find the sixth term, and that's equal to -1 raised to that 6th power, and then that's times 6 squared, and that's going to be equal to -1 to the 6th power, which if it's to an even power, that means that all the negatives are going to cancel each other out, so it's just a plain old 1, and that's going to be times 6 squared, which is 36, so that means the sixth term is going to be equal to 36, so that would be the answer that we would put in here, that the sixth term is 36, and of course it does fulfill our pattern that it's like negative and positive, and negative and positive, and negative and positive. So 36 would be our sixth term. This is the sixth term. Okie dokie. Okay, so hopefully that helps. And just click the like button, subscribe to the channel, and we'll see you back soon. Thank you.